Okay, can I have your attention, please? So I'm Joe Giammi, the head of the Laser Interferometer Gravitational Wave Observatory in Livingston here. And I'd like to welcome everyone here today as the American Physical Society presents us and our sister site, LIGO Hanford, with plaques designating these places as APS historic sites, historic physics sites. It's my job to welcome you to LIGO, which feels kind of weird because so many of you present have been partners, supporters, participants, and founders of the enterprise. So I guess I should say for most of you, welcome back. So the story begins about 100 years ago around I feel compelled to say, around the time my immigrant grandparents arrived. Albert Einstein's general relativity and a prediction of gravitational waves were published in 1915 and 16. And then around 50 years passed before physicists, beginning with Joe Weber, gathered the courage to attempt its measurement using metal bar antennas. Louisiana State University brought in a young Bill Hamilton in 1970 to follow that path at its campus, planting a seed here in Louisiana in the Long Enterprise. Ray Weiss, who will speak last today, began a different path at MIT around the same time, soon joined by Ron Drever at Caltech and other pioneers in Europe, developing a plausible design for a much more sensitive Michelson interferometer detector. Fortunately for the community and the world of science, experts at the National Science Foundation, empowered by the taxpayers, supported it. We're grateful today to welcome back program and overall leaders of the NSF who worked so hard to responsibly fund this very long-term, high-risk project. So after a fine proposal from MIT and Caltech, this is the proposal, in 1989, when I was still a Ray student, the National Science Board gave approval in 1990. That was a really shocking thing. Proposal in 89, NSB approval in 1990, leading to a search for sites. LSU and the Livingston Economic Development Council submitted this proposal. And out west, the Hanford management submitted this proposal. And they were paired forever. And that's why some people ask me, why is LIGO here? Well, fair and square, it was a proposal. Louisiana promised the land we were on, a new state road, the driveway you came in on, and the hiring of 2 new assistant professors. Those formerly new young professors are here today, myself and Gabriela Gonzalez, who went on to become the elected spokesperson for the entire collaboration at the time of the discovery, leading 1,000 opinionated colleagues to understand, analyze, and publish what became one of the most cited papers in physics. So LSU kept its promise, I think. Mike will say more about what went on in Hanford. So the 2 observatories were built, detectors installed, commissioned. We reached design sensitivity not long after Hurricane Katrina. I'm using Louisiana time here in 2005. Some of our visiting scientists who built the thing lived in a travel trailer over there because it was hard to get hotel rooms at that point. It seems like yesterday. And the 2 guys who did that are still very close. So nothing was seen in the run that began then at design sensitivity and a subsequent one, but then finally, you know the end of the story. The NSF and our British and German partners funded something called Advanced LIGO, which brought us to discovery in 2015. So not long after Livingston was built, we partnered with Southern University and the San Francisco Exploratorium to build the Science Education Center that you saw on your way in behind you. And it's that and similar efforts of Hanford have led to over 200,000 children and family members and members of the public being exposed to our programs here, which seemed like a lot when I first wrote down the number, but people have been working on that a long time. So my job, as I said, is to welcome you and introduce some of the speakers. So let me call out a few people who were kind enough to come. Members of the representing Mike Ebby is the Director of Special Projects for Senator Bill Cassidy. And Paul Sawyer is representing as Chief of Staff U.S. Congressman Garrett Graves. Here. Finally, let me introduce some of the people whose names are actually on this proposal, or whose organizations are on this proposal. The Livingston Economic Development Council sent David Bennett and Abigail DePino, you'll meet more LSU people soon. Okay, so here from have this all in the wrong order. I'd like to introduce some people who made it all happen, who aren't speakers. So in I believe alphabetical order from Marie, Beverly Berger, a former program director for gravitational physics at the NSF, who made so very much of this happen. Joe Bordogna, acting deputy director of the NSF. Claude Canizares, representing MIT, who, as near as I can tell, held so many offices there that I lost track when writing it down, but I think he now has the best job of being a professor of physics. Denise Caldwell, who runs the physics division at NSF now. Mark Coles, the current program manager for LIGO at NSF, who incidentally once had my job. The director of the NSF, Franz Cordova, will be speaking soon. Bob Einstein, former MPS assistant director, I think. And Richard Isaacson, who I think is the founding gravitational physics program director, who made it possible to be funded to do experimental gravitational wave physics. Ann Kinney, the MPS assistant director at NSF. Jack Lightbody, the deputy assistant director of MPS, and Pedro Marinetti, gravitational physics program director, and Jim Olvested, the chief officer for research facilities, I guess kind of like this one, at the NSF. Representing Southern University, Steve McGuire, long-term physics collaborator, Laurel Young, who has been collaborating with us on the Science Education Center since its very beginning, and Mike Stubblefield, the vice chancellor for research at Southern. Right after me, I'm going to introduce F. King Alexander, the current president of LSU, to make a few remarks. Stacia Haney, the provost, is here. Jim Wharton, the chancellor emeritus, who was greatly involved in the production of the proposal that I just waved around, is here. And Warren Johnson, who I wish were here, found the site wearing his own tall boots. Finally, David Shoemaker and Laura Cadenati are the current LIGO Scientific Collaboration spokespersons and a deputy spokesperson. And Gary Sanders, in a category all his own, was the deputy director of LIGO when it actually became real. So with that, allow me to introduce F. King Alexander, the president of the LSU system.
Thank you, Dr. Giammi, and welcome. Welcome to this great facility. Welcome to this great discovery. And it's rare to have such unanimous appeal at knowing that this was indeed the discovery of the year 2017, and it just continues on today. Where we stand today is on LSU property. It's the result of a lot of vision, a lot of risk, and a lot of investment by individuals, by leaders of science, university administrators, state of Louisiana, including our former LSU Chancellor, James Wharton. LSU's investment into gravitational wave science spans more than 4 decades back. That's a lot of risk to hang on to something that long and that type of belief, and is among the longest of institutional contributions and collaboration of any scientific endeavor that we've embarked on, and I know NSF and so many of our National Science Foundation individuals have been so committed to this. Today, LSU faculty, students, and research staff, including Joe Giammi and Gabrielle Gonzalez, we thank them for their contributions and representing this university all over the world on this very important, significant discovery, and their major contributions of the over 1,000 member team that made this happen, that was a part of making this happen. LIGO's designation as an important site in the history of physics is an honor for all of us today, an honor for those 1,000 members, honor for the discoverers, but an honor for LSU as well. And we thank everyone for being here on this important day. A couple things that really are significant to me is the fact that when something like this occurs, it gives us more ammunition in our state legislatures to talk about the importance of discovery and research. Because this is not just a Louisiana fight, this is a national fight to get our state legislators to understand how important scientific discovery and applying those results into things that we can improve, whether it's in health, the economy, education, and above. And anytime we can have a discovery of this type of magnitude, you talk about the ramifications and the waves that go around the United States and convincing others of the need for continued investment in science, research, and discovery. And most importantly, I appreciate the work that everybody has done in this facility with our grad students and our students. It was 2 students at 4:23 in the morning, a.m., that helped discover this international renowned Nobel discovery. And 2 grad students, one from Southern and one from LSU. That's truly remarkable. That's pretty good to put on your resume when you're applying for a job. I'm not sure they can top that in the future. But also, this type of discovery also pushes and encourages many others to go into science. And as Dr. Rainer Weiss told me just a few minutes ago when he gave the commencement speech at our College of Science, he noticed that 50% of the audience, 50% of our crowd, of our graduating student population, were women. 30% were African Americans. Many were first-generation students wanting to study science. This year, we have over 50% increase in students wanting to major in science coming to our university. So don't underestimate the value of this facility on the young minds of tomorrow and the young researchers of tomorrow, because this truly has had multiple impacts. And I think particularly on those numbers that I just shared with you, on the female population, on our underrepresented population, on our first-generation population, and all the incoming freshmen who are looking towards science education and to be the next researchers that carry this facility on for the next generations. So thank you to all the scientists, all the researchers, all the work in Washington for what you've done and having intergenerational impact with this great discovery, and for all the scientists and researchers who hung with this risk. Very few people, very few institutions would have hung with this risk like they did. And I thank our Washington partners, and I thank our colleagues all over the United States and this 1,000-member team for sticking with it, because you've truly had amazing intergenerational impact. And thank you all for being a part of this great celebration.
I'd like to introduce Dave Reitze, who's of Caltech, who's the director of the LIGO laboratory.
So I'd like to add my welcome to the many distinguished visitors who are here and the many people who really pulled this off. It's really an honor to be up here representing the LIGO laboratory. I should also point out this celebration is taking place right in the middle of an NSF review of the LIGO operations proposal. So we have a number of people in the audience who are reviewers who are looking at us very critically to make sure that we continue to do the kind of science that we've done in the past, and I want to welcome them too. So when I received word from Dr. Halpern, Professor Halpern, that we had won this award, I was initially quite surprised, because I thought to myself, well, we made these discoveries 3 years ago. The first gravitational waves came in September of 2015, so that's not that long ago. It seems a little short to have made history. But then I thought about it a little bit more, and I realized that no, this was exactly the right thing to do, because even though LIGO burst onto the scene as a worldwide scientific breakthrough observatory in 2015, this is something that's been going on for a long, long time. So 40 years ago, maybe even over 40 years ago, NSF, the National Science Foundation, started funding Ray Weiss at MIT to do prototyping for LIGO. Also in Scotland at the time, a professor who eventually became a professor at Caltech, Ron Drever, was working on gravitational wave detectors independently. And then, of course, at Caltech, we had Kip Thorne, who was thinking about the sources of gravitational waves. So this was all going on in the 70s. And the first time I heard about LIGO was actually when I was a graduate student in 1985 at the University of Texas at Austin. I had a course from a gentleman named John Wheeler. I think some of the physicists in the audience might know who that is, but just for others, John Wheeler was Kip Thorne's thesis advisor at Princeton, and then he moved to the University of Texas. And he was really one of the fathers of general relativity in this country. And he had a course called Problems in Modern Physics. It was a very interesting course. We didn't actually do anything very rigorous or deep, but what we did was talk about the interesting topics of the day and new science that was going to emerge. And one day, he passed out a Xerox of a newspaper article that was written in Maine, and I don't remember the name of the newspaper, but it's Columbia, Maine. And it talked about this, yeah, you know about this, Ray, yeah. I'm sure you do. It talked about this wonderful new observatory. Actually, they were going to build a pair of them. One was going to be built in Maine, which happens to be close to MIT. The other was going to be built in California, which happens to be close to Caltech. These detectors were going to cost $20 million, all right, which, if you know the history of LIGO, NSF has funded LIGO for about, I think, $1.1 billion over the last 40 years. So that was a little bit of an underestimate. But what it got right was the interferometer. There was a picture of the interferometer in the newspaper article, and it had well, it didn't have all the parts, but it had most of the parts. It had the Fabry-Perot cavities, it had the laser, it had the beam splitter, it talked about the vacuum system, so it was actually quite right in that perspective. So anyway, that's really how far back this goes. Now, Joe gave you a little history. Let me walk through a little bit more. As he said, in 1990, the National Science Board approved LIGO construction, and in 1991 is when Congress actually appropriated LIGO's first year of funding. In 92, Hanford and Livingston were chosen, not Maine and California, but Hanford and Livingston, and we really like these sites. They've proven to be very good for us. Construction of the observatory started in 1995 and went through 1999. In 1997, an organization called the LIGO Scientific Collaboration was formed, and this is a collaboration not just of the people who are working on LIGO at Caltech and MIT, but also a much broader group of people, including LSU, for example. In fact, LSU was a charter member of that collaboration, to carry out the science of LIGO, because it was going to be a really big endeavor. The initial LIGO interferometers started operating. They were constructed in 1998 to 2002, and they started operating from 2002 to 2010. Now, it's quite interesting. We are now operating advanced LIGO, which is the second generation detector. The initial LIGO detectors did not detect gravitational waves. Having said that, though, they were very successful. And the reason I think they were very successful is because we showed that you could run an observatory like this, and you could make a detector that could detect something that is mind-bogglingly small. I mean, we're trying to detect displacements that are about 1/1000th the diameter of a nucleus of an atom, and that's pretty impressive, I think. When I first heard about it, I actually thought it would never work, but then I started digging in, and I learned how it actually would work. And then we built advanced LIGO. That happened, we started really then 2010 to 2015, and then we started operating, and literally almost the day we turned on our detectors, we detected the first gravitational waves from these colliding black holes. Now, I want to point out that a great deal of people, including many people in this room, have worked very hard over the past 40 years in different roles to conceive LIGO, to design it, to fund it, to build it, and to carry out the science of LIGO. And really, we're here to celebrate, I think, everybody's contribution. So let me quote David Shoemaker. He probably didn't know I was going to quote him, but I will. This was from an interview that I read with him, and he said it this way. He said, "LIGO is a scientific endeavor that requires the synergy of many different minds working together. It takes more than a village. It takes a city to do this kind of science." I think that's quite apt. I'm going to quote somebody else. Nicole Washington, who's not here, is a property logistics manager for the LIGO laboratory. She's based at Caltech. She travels to LIGO, Livingston, and Hanford Offend. Here's how she put it, slightly different, but I think equally eloquent. One person can make a difference, and every role is important, no matter how small. Whether you're a physicist, an engineer, an accountant, a custodian, your role within LIGO is just as important as the next person's. We climb to Nobel status as a team, and there is nothing that any and all team members wouldn't do to ensure that LIGO is successful in its mission to measure gravitational wave. I really like that quote. When LIGO was first proposed as a big, large-scale project, it was met with a great deal of skepticism, and I'm sure many in the room remember that skepticism. Some deemed the project too risky and too expensive when you would compare it to other kinds of, say, observatories. Others felt that gravitational waves would never be detected. Chance of failure was very, very high, and the scientific payoff at the time was by many deemed to be too low to actually justify the investment that the National Science Foundation made. However, the NSF had a different idea. And I'll point out in particular Rich Isaacson, who's in the audience, and Marcel Baudon, didn't believe the detractors and the naysayers. They had the foresight to fund in the 70s Ray Weiss and Kip Thorne doing the tabletop R&D and the gravitational wave theory to be able to carry out this mission. They had the vision to go big, right? And if you've been to LIGO Livingston, you know we are a very big place here. And keep it going for the last 40 years. So this is really the long game. It took 40 years of time, but thanks to NSF's commitment and generous support, I think LIGO has delivered a stunning scientific payoff. Thank you.
It's my great pleasure to introduce Franz Cordova, the Director of the National Science Foundation.
Good morning. It's really a pleasure to be here, and it's an honor to represent NSF, this momentous event, when others of you have worked so long and so hard at NSF to help make this happen. So let me join Joe and President Alexander, David, and all in welcoming everybody. For some of it is back to Livingston, back to LIGO, to get to once again relish in its discoveries and the invention that caused it to be the great observatory that it is, in partnership with Hanford and with Virgo and soon to be others around the world. And I want to also welcome our colleagues from the American Physical Society and scientists, of course, from the LIGO Scientific Collaboration, which I must say, one thing I've really learned is that is a model for a big team. And we use it often when we talk about team building at NSF and elsewhere about how a giant community can really come together with selflessly and work on something so important, and it's a worldwide community. Also, members from Caltech and MIT communities, of course, the university community, just represented so ably by President Alexander, and NSF management staff, all of us here together to celebrate something new and important, namely the dedication. It's hard to believe that it's been more than 2 years since many of us were at the National Press Club announcing LIGO's detection of the first direct evidence of gravitational waves on Earth produced by the merger of two very large black holes in a binary system more than 1 billion light years from Earth. Since that announcement, of course, there have been other significant discoveries. They just keep coming, including evidence of the dramatic merger of two neutron stars and the confirmation of that merger from many ground-based and space-based observatories around the world. And that was just a huge highlight for all of us participating in that discovery. And it actually, President Alexander made the science breakthrough for 2 years in a row because of that discovery. We also had the pleasure last year, and I want to again thank Ray Weiss and Barry Barish and Kip Thorne to give me a personal invitation to go to Stockholm and see them get the 2017 Nobel Prize in Physics, quote, for decisive contributions to the LIGO detector and discovery of gravitational waves. That was just an amazing moment, and I'm sure, Ray, you're down here somewhere. Can't really see you. One thing I can't overcome is being short. And just to see the look in their faces, all of us who got to be here. And there were many, and that was because of our 3 Nobel Prize winners. They assured that many, many people could join them to celebrate that. So we've really been witnessing history in the making, and it's such a great thing when you grow up reading history books about monumental discoveries and theories that became discoveries and all, to realize, to pinch yourself, as David was, I think, intimating, and realize that you are part of that history, your own role, no matter how small or how big important it is that you get to be part of a living history that's still evolving and is still about, I think, to show us many amazing new things. NSF would like to really thank MIT and Caltech for their persistence, their vision that helped turn the concept of a laser interferometer gravitational wave observatory into reality. And we're indebted to colleagues around the world, and I got to go to the Virgo Observatory last fall to see that beautiful facilities, and for their seminal contributions to all this. And let me just take a moment, because President Alexander mentioned legislators, that we have some real supporters in Congress, among the senators and among the House members. We have champions of science, and I think if you've been following any of the recent news with the House and the Senate markups for FY19 for the National Science Foundation, the future looks very good indeed, and that should make all of you who have bigger and even bolder ambitions for this observatory and beyond, for gravitational wave observing into the future, should really literally put more stars in your eyes at all the possibilities that are before us. So I do think we should always remember when we're in DC to go by their offices and personally thank them for championing this discovery and so many others. I know Chairman Culberson, who's our House appropriator and is so important for the vitality of the mission at our foundation and how we're able to enable science and engineering, is just when some of you, I think, have experienced his amazing delight in science. And there are many, many among our legislators who are like that, who just simply want to know more, who want to be in your presence, have you tell them the stories, have the opportunity to ask you questions about the science. The LIGO team involved people at so many different skill levels and interests, including, of course, our students, who, as we heard from Joe, then become, the leaders and take us to new places. We know that there are more than 1,200 scientists and some 100 institutions around the world who have all provided crucial contributions. This commitment to the LIGO vision has opened an exciting new observational window that allows us to see our universe and some of the most bizarre phenomena in it in an entirely new way, and reveal to us things like, have any of you in the Science Education Center, I was just introduced to a new exhibit this morning where you see people playing basketball. Have any of you done that exhibit? Okay, that is really, really interesting. So I was walked through it this morning, and you're looking at the basketball, and you may not notice that some new dark thing comes into the picture and then leaves the picture because you're so focused on the ball bouncing on the floor. So you have to watch it per instruction of this exhibit. You have to watch it again to look for the bizarre phenomenon. And that's kind of how this all happened. We were looking for something so intently, and we didn't realize it would be accompanied, that in the picture would be these amazing large black holes in a binary system, and then these neutron stars who, besides producing gravitational waves, also give us things like the metals we wear on our fingers and so on. So the universe is indeed an extraordinary place, and we're just also fortunate not only to get to be in it, but to get to understand it and to develop the tools to keep furthering that understanding. As you heard, since the early 1970s, the National Science Foundation has been funding the science that ultimately led to LIGO's construction. At the time, LIGO was the single largest investment NSF has ever made. It was a big risk, but I think it set the stage for other big investments, so the sky's the limit. We're on the way to doing bigger and better things, including for gravitational wave observing. That's the mission of NSF, is to undertake the kinds of things that scare others. And every day we have the scientists who are just really keyed in on that mission to take fundamental science to new points along the path to discovery. So we fund trailblazers, and that funding is a major reason why the U.S. continues to be a global leader in advancing knowledge. While LIGO has produced spectacular and inspirational science in the last few years, this is only the beginning. The gravitational wave universe is almost completely unexplored, and the next decades will undoubtedly produce new, unpredictable, and exciting new insights into our universe. And I pray, along with all of you who have been on this planet for a very long time, that we live long enough to get to see a whole lot more. One of NSF's 10 so-called big ideas is called Windows on the Universe, a new era of multi-messenger astrophysics, a vision for the future of discovery. And indeed, we've already started on that vision with the electromagnetic plus gravitational wave discoveries connected with that neutron star merger. Using a powerful array of telescopes all around the world in our gravitational wave observatories, we have begun that approach to observing the cosmos. And I think we're going to shortly hear much more about where that will lead us. So again, this is just such an exciting time. I'm just thrilled to be back here at LIGO. I want to thank all the staff who work here every single day for their great work in making this a tremendous place to do science and also to explain science. What a marvelous, marvelous thing it is, this education center. I always revel in what I learned from that. Thank you so much for all your contributions, each and every one of you, and I'm proud to be among you. Thank you.
Okay, we're getting closer to these plaques here. I'd like to introduce Paul Halpern from the American Physical Society, who chairs the Historic Site Selection Committee.
Hello, on behalf of the APS Historic Sites Committee, I'm delighted to be here. As David Lightsey mentioned, it was kind of an unusual pick. It's our first 21st century pick, but of course the history goes very far back. Experimental attempts to discover gravitational waves go all the way back to 50s and 60s. So this is something that is recognized by the committee. This is a lot of history. Of course, theoretical ideas go back more than 100 years. So my committee has honored more than 40 sites spanning many centuries. First site honored was Benjamin Franklin Memorial in honor of Benjamin Franklin. And this honorary is unique for many reasons. First of all, it's the first 21st century site. Also, I was really pleased that the American Physical Society was able to provide dual plaques, one for each observatory. and also to indicate the dual waveforms on each plaque. So this is really unique among our historic plaques. So I think we find, especially among the larger sites that we've honored, such as, for example, Fermilab and Los Alamos and so forth, consistency of funding has been one of the things that's made the larger sites bring forth discoveries. So this is a great example. Everyone appreciates the funding of the National Science Foundation and the consistency of it, that there was consistent funding for many, many decades. And we see as a unfortunate negative example, SSC, where Congress abruptly cut off funding to that site, and that didn't make history, unfortunately. So looking to the future, I think we want to call upon scientific foundations and the NSF to continue to fund discoveries over large experiments over multiple decades, because we don't know when certain experiments will bear fruit, as this did brilliantly a few years ago. Now, I wanted to mention that for the sites that we have, going all the way back, we keep a historical register of all the sites, and these are signed by someone from the site, and also the current president of the American Physical Society will sign this. The last event we did was in honor of Bob Dickey at Princeton. And interestingly enough, by coincidence, Kip Thorne and Ray Weiss were there. They have connections to Princeton and gave excellent talks there. So this is in a way, a kind of continuation, or maybe that was the prequel to this event, the Bob Dickey event, which was so nice. And in general, the last few years, we've seen an upsurge in interest in gravitational research in general. We had not only the LIGO event, but the Bob Dickey event. We honored Einstein's birthplace along with the European Physical Society, which was the first joint APS event with the EPS. We honored the Institute for Advanced Study. And then, going way back, we honored the Penzias-Wilson experiment. But more recently, a number of gravitational research projects have been honored by the APS group. So that's really wonderful. So at this point, I would like to call upon the director of LIGO, Dr. David Reitze, and the APS president, Dr. Roger Falcone, to come up and sign the Historic Sites Ledger. It would have to be both, and there's only room for one person. There's only room for one space. I mentioned,
actually, why don't you...
Unfortunately, there's only one space for the signature of the site.
Thank you very much.
Thanks, Paul. Thanks, David. It is my real pleasure to be here to name the Laser Interferometer Gravitational Wave Observatory, it's a mouthful, as an APS historic site, both in honor of the discovery of gravitational waves, but also I see it as a harbinger for the future in the sense of the signaling of the birth of multi-messenger astronomy that Franz mentioned. It's going on now. So it is looking to the future. I want to thank David for putting together this program. Thank Caltech and MIT for their monumental contributions to the LIGO effort, and of course express APS's appreciation to the National Science Foundation for its critical support in supporting the LIGO discoveries. On a personal note, I've been involved with LIGO in various ways at the periphery, I would say, for a couple decades. I was on original NSF reviews We talked a lot with Ron Drever, with Robbie Voigt early on in the project, had great respect for their efforts to help launch this project, but also great respect for the ability of NSF to help, and Caltech and MIT to move the project forward. Some of my favorite moments at those times reflect my other personal view of this. So the first view is that NSF was so diligent in moving the project forward, so committed to it, and I could see that as I was part of their reviews. The second piece of it was the fact that LIGO is such a beautiful technical and scientific project. Some of my really fun moments were sitting at tables with Ray arguing over some technical issue. I remember bending metal that was coated by glass that was part of the baffles in the system, arguing it was going to be a dust problem. I think you have dust problems, but they're different dust problems than that one. But it was just so much fun to engage technically on these issues that people knew so much about here. It was great fun. So the American Physical Society, for those of you who are not familiar with it, is a society of about 55,000 physicists from around the world. We promote physics in various ways, and we help disseminate the results of scientific research, and recognizing these kinds of contributions are part of our role as a society. As Paul mentioned, we have named 40 sites around the country, around North America, with this designation as a historic site. So I will read the plaque citation. Some of you might not be able to see it today. Hopefully you'll come up and see it, but it says, on September 14, 2015, LIGO interferometers at Livingston, Louisiana, and Hanford, Washington, made the first direct observation of gravitational waves. The precision required to detect these tiny disturbances in space-time caused by the merging of black holes was made possible by the coordinated labor of over 1,000 scientific and technical workers. So this plaque for this site and a companion plaque at the other LIGO site recognize their contributions to this historic detection. So that's what the plaque will read. So there are appropriately 2 plaques for the 2 sites. I see this again as somewhat of a harbinger for the future. We couldn't honor the discovery by 1 plaque, it took 2. It's reflective of the fact that this is team science that we're engaged with here. Each, as you see, is engraved with the dual waveforms of the first gravitational wave signals that, of course, were detected at both sites. So I look forward to the placement of these plaques. I'm not sure it's decided exactly where we will go, but we'll look for a spot with great permanence here to reflect this historic contribution. Thank you very much.
So I'm happy to introduce my counterpart at LIGO Hanford, Mike Landry, and who will talk about accepting the plaques and so on. All right.
Good morning, everyone. You know, if we celebrated like the Washington Capitals with the Stanley Cup a few weeks ago, we'd be carrying these plaques around the control room over our heads. Thank you, Joe. Thank you, Joe. For those of you who don't know me and expected to see the longtime figure of Fred Robb up here, I'm relatively new at this, observatory head for just 2 years. So think of me as the Joe Giammi of LIGO Hanford. So honored guests and observatory colleagues, it's my great pleasure to thank the American Physical Society for designating the LIGO observatories as historic sites. The marking of LIGO Livingston and LIGO Hanford observatories for the first direct detection of gravitational waves caps an odyssey that first began, for the most part, for many of us, on September 14th, 2015, waking early to a loud signal in both detectors, frantically trying to understand at first. It was something we made ourselves, injecting into the machines, followed by many weeks of meetings, debates, investigations, and finally, the understanding that the signal was real, that the first detection had been made, and that a new field of astronomy was on us all. The two observatory sites are quite different. LIGO Hanford, set in the arid shrub steppe of the Cascade Mountains in Washington State, and LIGO Louisiana, LIGO Livingston, here in the lush forests and bayou of southeastern Louisiana. But the laboratories are populated by similarly driven people, talented individuals with a deep sense of focus, and a seemingly ridiculous optimism that we could sense space-time modulations at the level of 10 to the minus 19 meters from some cataclysmic event far across the universe. It is, of course, not only the people at the sites that made this possible, discoveries of binary black holes and neutron stars, but those dedicated scientists, engineers, technicians, and administrators at the Caltech and MIT campuses, those in the LIGO scientific collaboration, our friends and our partners in the Virgo collaboration, and those who have enabled the entire enterprise in the first place at the National Science Foundation, and finally, the taxpayers who foot the bill, both the US and international partners. The first powered flight of an airplane by the Wright brothers is marked in Kill Devil Hills, North Carolina, with a bronze tablet set in granite. There, visitors can connect with the past. Imagine that moment, the pioneering spirit and the sense of adventure that motivated it. Now with these plaques, people will be able to do the same when visiting our sites, and the gifted outreach staff of LLO and LHO will be able to make that experience more real for them. There's a beautiful inscription on the plaque. Roger just read it. If you read it closely, you'll see that Livingston Observatory is listed first and Hanford second. We're not competitive at all. I think that's a nod to the order in which the signal was received, Livingston first, Hanford second. And I find it a little ironic that it took 1.3 billion years for that signal to get here, and yet when it was detected by the sites, it was separated by 6.9 milliseconds. That's about 1 part in 10 to the 19, or 10 to the minus 19 again. The astronomer Vera Rubin once said, "Don't shoot for the stars. We already know what's there. Shoot for the space between, because that's where the real mysteries lie." I like to think that once this is the sense in which we approach our experiments, and that perhaps LIGO has taken it one step further, that we shooting for the space between the stars, and in doing so has unraveled some of that mystery. We intend to mount these plaques at each observatory site on rock outside the front entrance of the primary visitor buildings. At Hanford, we'll make use of local basalt, rock, evident throughout the eastern part of Washington state, carved out of the scablands by 2 million years of ancient glacial flooding, when our first gravitational wave signal was over 99% of the way here. In this way, our visitors will be able to marvel, as we do, at how the seed of an idea that began in Einstein over 100 years ago developed into theory, into experiment, into detection, and into a worldwide enterprise of collaborative multi-messenger astronomy. In closing, and on behalf of the LIGO Livingston and LIGO Hanford observatories, and of the LIGO laboratory overall, I want to thank the American Physical Society for designating these historical sites for 2018. We will relish sharing these beautiful plaques with our visitors, especially the many thousands of school children that are inspired by site visits every year. Now let me turn the podium over to Ray Weiss. Ray is really a person that doesn't need any introduction, but let me tell you briefly about my first week as a postdoc at LIGO Hanford Observatory in early 2000. Ray was visiting, as he often did, and he showed up at our daily control meeting, our daily meeting in the control room, having just been stopped for speeding on the 240 highway by the local Benton County Sheriff. Ray was dressed in his characteristic blue button-down Oxford and black down vest. And honestly, I considered co-opting this look for a little while, Ray, but I resisted. Ray described how he'd been stopped, but let off with only a warning once they had seen his Boston driver's license. Incidentally, how much would it cost? Asked Ray. And the sheriff replied, $120. But with taxes and fees, it would be $137. And really, Ray answered, because that's a really important number. It's 1 over the fine structure constant.
Thank you for coming, first of all. This is wonderful. Absolutely wonderful event. And I want to give a good bit of credit to Bob Eisenstein. Where is he? Just stand up. Bob had this idea, and we couldn't bring everybody to the Nobel Prize, but we brought a lot of people to the Nobel Prize. But he said, why don't we have a special thing? And the idea was sort of generated by both of us here in Livingston for people who really deserve to be part of the celebration, and that's all of you people. So thank you for coming. I just want to say the same thing everybody else has said, but I said it in my own way. And that is that I want to say something that this is due to the work of scientists, clearly, students, lots of students have been here at both sites. Engineers have worked with scientists together in a very friendly and convivial way. Administrators have helped enormously. And so consequently, this is really, as has been said by all of us, this is a joint project, and virtually everybody played a very big, important role in it. So, but I do want to say something special about the NSF. And that is that you have to consider back in 1970, in the middle 70s, when this idea began, and Rich Isaacson was had just come to the NSF as head of gravity in the physics division. He listened to a bunch of flakes. I mean flakes. You know what flakes are, right? Yeah. Who wanted to do this, and that was both Kip and Reaver came a little later. He was a flake also. And what happened is that we then proposed the beginnings of something like this to Rich as something which, well, let's think about why it was so remarkable that he even listened to us. It was that we didn't have the technology in hand yet. We knew about what we could do, but we didn't have it yet demonstrated absolutely at the level that was required. And worse still, even if the technology was made to work by our hands, we didn't know exactly what we would see. I mean, the idea of what you might find as a source was not all that well defined. And nevertheless, Rich and the NSF, and he convinced Marcel Barden, who was his boss, and they together they convinced the rest of the Science Foundation that this was a good thing for the NSF to get into. Why? It had all these interesting uncertainties. It had something good for industry, probably, and if it should work, it would be transformative. And so I think this is, to me, the major story that you have to say is just wonderful about the NSF, that they took that gamble. And so consequently, I'd like to ask France to come up. I have something I want to give to France. Yeah. And I may need a little help from you, France. Let's get this apart. Here we go. Now, what this is, and you'll recognize right away, is a replacement or an addition to a picture you already have at headquarters.
Oh,
let me come around and explain what it is. Come over. If you go to the new headquarters of NSF, you'll see a picture of Vannevar Bush. Now, who is Vannevar Bush? Vannevar Bush was effectively FDR's science advisor. He helped us get through the Second World War. He forced the country into looking at what you could do with science if you want to deal with Hitler. And they pushed the radar project through at MIT. They pushed the underwater sound project at Harvard through, the proximity fuse project at Johns Hopkins. and then the big bomb project that followed. And that was all due to Vannevar Bush, in making meckering, as they say in German, in Roosevelt's ears. So now, this is a picture of Vannevar Bush. He was a professor at MIT, had become dean, and at the time when this picture was taken, he was probably head of the Carnegie Foundation, I suspect. And what's there, you'll see, in this picture is Vannevar Bush sort of leaning on a milling machine. And in the bottom of the milling machine down here is a little piece of aluminum he's just made a cut through. When this picture, I tried to get this picture from the MIT museum. It didn't happen. It turns out the people who had this museum is Marvin Koner, K-O-N-E-R. And it turns out that they misplaced it. They said they gave a bad title to it. It said Vannevar Bush with a drill press. And I've had endless conversations about them. This is not a drill press. Anybody? And then they screwed it up again. They said, well, a milling press. And that's wrong too, because if the boss of the shop had caught you using a milling machine as a press, he would have fired you. So anyways, I think they got it right now. Now, I want to give it to you because it's a wonderful picture. In fact, it should be in collaboration with the picture you already have. Now, why is it given to the NSF? And why is it so important? Because after the war, Vannevar Bush wrote a book called Science, The Last Frontier, The Endless Frontier. If you read that book, you'll find an interesting thing in that book. It has in it all the reasons that people have given Congress why we want to do science. It's good for defense, it's good for people's health, it's also good for education, it makes industry innovative. But at the end of the book, he spends a good bit of time saying it satisfies something that man needs to be satisfied with. The curiosity he has, and she has, about what's around us and how it works. And the pleasure of understanding. And that is what came out. What came out of that last piece is the National Science Foundation. He proposed the National Science Foundation as for that last element. And you've done very well. Thank you.
You've given us a lot of pleasure.
You have to find the piece of...
Right here.
You found it?
Yeah.
Are you sure it's in there?
Yeah.
Okay, good. Let me put it back, but let me do it off the stage.
Okay.
I felt it was best not to put a frame on. You probably should think
There's really no following that. Thanks, everyone. There is following that. It turns out that lunch is under the covered area across the street, I believe. So, in 10, 15 or 20 minutes, something like that. I haven't been out there, so I'm not really sure what's going on now, but.